Hey y'all, here is your notes key for identifying functions. The goal here is to identify functions using graphs, tables, lists of ordered pairs, and mapping. So first we're going to talk about relations. Relations are a set of ordered pairs that can be represented by lists, graphs, tables, and mappings. Okay, so looking at our examples down below, we can see that a list is simply, the coordinates written out or the ordered pairs written out, x comma y. And then within our table, x values must be least to greatest, which we can see that here they are. And then our graph, I went ahead and graphed our points here. And then for mapping, you must list inputs and outputs least to greatest. Okay, so both inputs and outputs must be written least to greatest. So make sure that you don't include any repeating x or y values. So you'll simply just write any of those repeating x or y values once and then draw arrows to connect them. So I'll go ahead and write my inputs in. Looking at my table, I have -1, 0, and then here I see that +1 is listed twice, so we'll just simply write it once, and then +3, and then for output, same thing, you write it in order from least to greatest. So starting with -1, +3 is written twice, so I only need to include it once, 5, and then 6. And then I'll use my table to kind of draw my arrows from input to output. Alrighty, and then here we'll talk about how a relation is considered a function when every input gives back exactly one output. So when there are no repeating x values, essentially. And so let's look at some functions. So let's talk about some functions. Okay, so a table represents a function if every x gives back exactly one y. So kind of like I mentioned, there are no repeating x values. Okay, because when you have repeating x values, you have more than one y value. So looking at our example, number 1, it asks if the table below represents a function. Well, are there any repeating x values is essentially how we can figure that out. And yes, we see that +5 is given as an x value twice, so no, this is not a function. Okay, looking at number 2, are there any repeating x values? No, so yes, this is a function. Looking at number 3, does every input give exactly one output? So does every x value have exactly one y value? Or are there any repeating x values? Well, yes, there are, because we can see that 0 is given as an x value twice. So no, this is not a function. And then looking at number 4, again, same thing. Does every x give back exactly one y? So are there any repeating x values? And no, there are not. So yes, this is a function. Okay, now we're going to look at identifying functions from graphs. So a graph represents a function if it passes the vertical line test, and I'll go ahead and talk about what the vertical line test is. Okay, so one way to see if a graph represents a function is to kind of pick the points. Okay, so I'm going to pick 2 points that pass through a line here and then same thing over here, okay? And then you just draw a line through those points vertically, okay? So you draw a line through every one of those points vertically, okay? And does the vertical line pass through more than one point? If it does, that's a good way to know that it is not a function, okay? Because for a vertical line to pass through more than one point, that must mean that it has the same x value. And remember that we cannot have repeating x values. So every x value has to only have one y value. Therefore, the x value cannot be repeated more than once. So this is not a function. Okay, looking at number 2, does this pass the vertical line test? Well, we can draw a line through every point and see that there's only one point that passes through each line. So yes, this is a function. Okay, what about number 3? Does this pass a vertical line test? No. It does not, because there's clearly, obviously, more than one point passing through this line going on here. And then number 4, drawing out our vertical lines. Does this pass the vertical line test? No, it does not, because more than one point goes through each line. And moving on to mappings. So a mapping represents a function if every input gives exactly one output. So if every arrow, or if every input arrow is only pointing to one x value, essentially. So let's look at number 1. Does every input value point to one output value? Well, we can see, looking at the first value, -4, that it points to 2 output values, therefore it is not a function. Okay, looking at number 2, does every input value only point to one output value? Yes, it does. So that is a function. Number 3, does every input value only point to one output value? And yes, it does. So every x value only has one y value. Okay. And looking at number 4, does every x value only have one y value? And we can see that yes, it does. Therefore, it is a function. Okay, and last one, looking at functions from list. This one might be probably one of the more simpler representations to decipher here. So a list represents a function if every x value gives back exactly one y value. Okay, so let's look at our first list. Is there any repeating x values here? That's one sure way to figure out if this is a function. There are no repeating x values, so that would make this a function. Okay, looking at number 2, are there any repeating x values, or does each x value only give back one y value? And we can see here there are 2 repeating x values and 2 y values, so no, this is not a function. Alrighty, moving on to our third list, are there any repeating x values here? And we can see that yes, there are, therefore each x value does not give back exactly one y value, and this is not a function. And number 4, are there any repeating x values here? We can see that no, there are not, therefore each x value gives back exactly one y value, and yes, this is a function. And that's it for your notes on identifying functions. You can go ahead and get started on today's practice.